Welcome to the first video in a series of videos on strings. I'm going to cover two specific topics in this video. First, I want to talk about some basic characteristics or properties that all strings share, and then I want to talk about how to iterate through strings two different ways. Now, I've covered iteration in some of the review of trimester 1 videos. You may want to check those out. There's a link up on the top right hand corner of this video that you can click to get there. Let's begin with the basic properties of strings. Strings are a built-in class in Python. That means they're just like the int or the float or boolean or any of those classes, which means we don't have to do anything special to use a string. Second, strings are sequences of characters. They're called strings literally because they're strings of characters. And because they're sequences of characters, they operate in many ways just like lists operate. And one of the ways that's true is that they are iterable. That means that we can walk through a string, character by character, in several different ways, and we'll take a look at those in a couple of minutes. Finally, and perhaps most importantly, strings are immutable. What that means is that once you create a string, you can't change it. Now, we'll do lots of things that look like we're changing strings, but what we're really doing in each of those cases is we're creating a new instance of a string and then perhaps saving it back and replacing the original instance. So keep that in the back of your head. It's a source of many errors for new programmers. There are two primary ways that we iterate through strings. The first way we iterate is to assign to a variable the next character in the string every time we go through the loop. In this case, ch will take on the next character in the string. In the second approach, we're going to loop using integers. This time, I is going to take on the values of 0 up through 1 less than the length of the word. And we'll use that index to grab the next character out of the string, and we'll do that until we've walked through the entire string. So let's go ahead and look at each of these in more detail. In this example, we're going to prompt for an input and store that to a variable called the string. And then we'll walk through that string character by character. On each iteration of the loop, we'll assign the next character to a variable called nextchar, which will then print out on the screen. Let's go ahead and use a string that's got a mixture of alphabetical and non-alphabetical characters. We'll use "this is too cool." And when we hit enter, we should get output that's 1 character per line. Now, having a variable that stores the contents of the next character allows us to very easily put in some conditional statements. For example, suppose we wanted to print all characters except for the letter I. Well, then we could add this conditional statement and then rerun the program. And when we run the program this time, you'll notice that neither of the I's are present. Here's a slightly more realistic but still somewhat contrived example that uses this technique of iterating. This function is supposed to help validate an email address by returning true if the address contains exactly 1 @ and false otherwise. Take a look at the 3 test cases, see if you can predict what the output will be, and walk through the code, make sure it makes sense to you before you actually continue the video. The function returned true, false, and false for the 3 test cases respectively, which correspond with 1 @, 2 @, and no @. We're going to modify that program to use the second iteration technique in a couple of minutes, but before we do that, I want to make sure everybody remembers slicing notation. And we'll spend a lot more time in slicing in an upcoming video. Right now, we're just going to talk about using it to grab a substring, and specifically a single character. You can grab any character you want out of a string by specifying the 0-based index of that character. So when we ask for the 0th character here, we're going to get the letter A. So what am I going to get when I ask for the character in position 6? Pause the video and check your answer before you continue. Well, we got the last character. I'm going to assign the string to a variable just so it makes it a little easier to type the next couple of examples. We can always use 0 to get the first character in a string, but how do we get the last character in a string if we don't know how long it is? Well, we can use the length function to do that, but we don't want to say length of c. We want to say length of c minus 1. Otherwise, we're going to be 1 beyond where we want to be. Remember, we're 0 based, and so we have to go to the length minus 1 to get the last character. So let's use that understanding to rewrite the program using the second iteration technique. We're only going to have to make a few very minor changes to rewrite this loop, and we're going to focus on these 2 lines of code. We want to iterate from 0 to the last position in our string, and we know that length of address minus 1 will get us that position, but it gets a little strange when we deal with the range object, because range always gets us from 0 up to but not including the last number. So we actually use this syntax, range length address. That's going to give us a range object between 0 and 1 less than the length of address, which is exactly what we want. Each time through the loop, we want to grab the character that's at the position specified by the variable I. And so we can say if address sub I is equal to an @ sign. And everything else should be exactly the same. And not surprisingly, we got the same results. We're going to use that same technique to write a function first upper that's going to return the position where the first uppercase letter in a string occurs. If it doesn't find an uppercase letter, if there are no uppercase letters, then it will return none. So we'll begin by creating a loop the same way we did last time for I in range length of the string. There are undoubtedly better approaches to this problem than the one I'm going to show you, but this uses only information we know so far. So I'm going to compare the character at a particular position to itself in uppercase form. So I'm going to say if the string at position I is equal to that same string's uppercase version, return I. And remember, I is not a character, it's an integer representing the position where it found the uppercase letter. On the other hand, if we make it through the end of the loop and we haven't returned I, then we should return none. I encourage you to pause the video and see if you can identify a logic flaw in our program right now that we'll fix in a couple of minutes. Let's take a look at what that looks like when we run the program with a few different inputs. For our first test, we'll put a capital letter in the 4th character, which, because we're 0 based, should return position number 3, and it does. But we have a few more test cases we should run. Let's try the case where there is no uppercase letter, and sure enough, it does return none. And we can make sure that if there are 2 uppercase letters, it just returns the index of the first one it finds, and it does. But let's see what happens with this string. Well, hopefully you identified the bug in our code. Let's go back, take a look at it, and find out what's happening here, and then we'll fix it. So the problem is a result of how the upper method works. Upper returns the uppercase version of a string, and in the case of a character, it returns the uppercase version of that character. Well, the problem is numbers and punctuation don't have uppercase equivalents, so their lowercase and uppercase are exactly the same, and therefore, for any punctuation or numbers, this if statement will return true. Well, here's one way around that problem. And this would be a perfectly acceptable solution, but it's not as efficient as it could be. And I encourage you to verify that this solution does in fact work. That first if clause becomes redundant, and this should get us the desired results. I'm going to run through each of our 4 test cases. Notice that I'm retesting all of the scenarios because when you make a change like we've just done, it's possible you've introduced new bugs. Of course, I'm going to pay special attention to the last one, the one that caused our bug in the first place. And as you can see, that one's working properly now. That's a good breaking point for part 1 of our strings video series. In the next video, we'll take a look at some of the most commonly used string methods, and time permitting, we'll talk about slicing as well. See you there.